Okay, good evening, everyone. So thanks Arno and Shubham for inviting me for the second time. I've been here in November, yes, to present something around logging in microservices. Today I'm going to speak about API authentication. How should we build it today? So let's start this talk. Who am I? My name is Léo Unbekandt. I'm a CTO and co-founder of Scalingo. Scalingo is a platform as a service hosting company. So basically, you push a code and 2 minutes later, your application is live and you can just use it and scale it and keep it working over and over. And Scalingo, since the beginning, is based on an API. We wanted to build a platform, and by platform, we wanted to let people connect to it and use it in a programmative way. But it was the beginning of a new company. The time was precious, and finally, the initial implementation of the API authentication was a simple single API token. So basically, if you wanted to use our API, you just log in with your username and password, you go to your profile, and then you see, hey, there is your API token, and then you can just use it and use it in your application to authenticate to our API. So it was a first version. I mean, there was only one token. If you revoke it by regenerating another token, you were disconnected from the command line client, from the dashboard, from any client you were using to reach our API. So it was not sustainable. Now we are bigger and we have other requirements, and we needed to build something more, yes, let's say serious. So what are the next-gen authentication specifications we wanted for our API? So first thing is that we'll be soon multi-zones or multi-data centers, and there will be APIs on each zone provided by the platform. And from this, we don't want the users to authenticate to one zone and then to have to authenticate to another. The authentications should be central. The second part is that in each of these zones, there are several microservices working. For instance, if you want to get the logs of your application, because each application is producing potentially a lot of logs, you have to connect to some WebSockets to get the logs in real time. If you want to scale your application, you have to reach our app API and so on and so on. And it is exactly the same thing. We don't want the people to authenticate to each service individually. They have to authenticate once and then being able to use the different services provided by the platform. And then obviously, it should be horizontally scalable because, yes, we're getting bigger and we don't want, it has to be sustainable over time, so it should be growing with us. As I said before, we are a platform, so we want people to build tools to automate things around the platform. So we want to let third-party applications using our API. And obviously, our main targets are developers. For that, it should be really convenient for developers to use our API. And obviously, it's authentication, it's security. It should be secure, yeah. So let's start with the first way one can see on the web how we can authenticate a user against an API. So first, we are at Algolia. I wanted to have a look at how it is built from the API. So basically, when you create an account on Algolia, you go to a profile, and then there are API tokens. That's one of the most common way to build authentication to an API. On GitHub, you have API tokens you can create for your own account. And that's more or less the same. So you just say, I want to create a token with this permission and this time to live, and then you have some Unix string you can use. Then how to use it when you want to, yes, query the API of Algolia. So here I can see I just opened the inspector in my browser. I've seen that there were some queries done to the API. The token was passed in query string parameter, so in the URL. Okay, so with API tokens, in general, there are multiple ways to communicate it to the API. And there is no standard here, precisely. According to the company, it can be really different. For example, for us, you use some HTTP basic-auth header. So with, for instance, with a curl request, yeah, it's here also. With a curl request, you can just say, hey, my password is my API token, and then we get it, and we authenticate you. I've just said with Algolia, it's passed as query parameter. Personally, I don't really like this way to do, because if, as it is in query parameter, it is usually the reverse proxies are logging them, so maybe you will have traces of the tokens in your logs, and having credentials in your logs is not something I like personally. So this method works well because for some, in a certain scope, that's why, yes, you can use it on GitHub, on Algolia, and other services. It fits great several cases. The first one is monoliths. Obviously, if you have one big server providing your API and all your services, it has the knowledge to understand the token and to allow or not a user to get resources from your API. It fits also when you have intelligent reverse proxy. It means all the requests are going to one reverse proxy, HTTP reverse proxy. It authenticates the request or not, and then pass the request to other services internally. I assume it's what Algolia is doing. Maybe they can tell us later a little more. But this solution has some issues. I mean, you can't use or make delegation with this. For instance, if I want to build a software which is using Algolia API, I can't ask my user to give me their token. It's cumbersome. They have to go to the dashboard of Algolia, creating a token and passing it to my service, and they have to be confident that I will use it just to do what I say I've done. That's why another standard has been built, which is named OAuth 2. That's something you have all used in this room, I'm sure, or maybe not, but it's pretty uncommon. So the first usage of OAuth 2 is when you want to sign in with some other provider. So for instance, again, we are at Algolia, so I use this example. When you're on the login form of Algolia, you can just say, hey, I want to log in with GitHub. You click on it. Then you are redirected on GitHub. You log into your account on GitHub, and then you have to give your consent that Algolia will be using your identity or your GitHub account to use the API. In this case, Algolia just wants the profile and the email of your account on GitHub to be sure that you're really authenticated. But it can be used for a lot of things. For instance, you can say, hey, I want to read your repositories or your issues or to do anything else. So it's just a scope. The most common is a profile for authentication, but you can do a lot of things with this. How does it work? So first, there are some, I am the resource owner. According to the standard, there are some official names. As resource owner, I own the resource, and I have the credentials to access them. So first, Algolia is redirecting me to GitHub with the ID of the Algolia app. So I log in on GitHub with my username and password. Yeah. And then GitHub is telling me, Algolia wants to use your API, your account to use our API. Do you allow it or not? And then I have to give my consent. And once I have those three things down, GitHub is returning me a token I have to give to Algolia. That's the third part. And then Algolia internally just have Algolia as a secret. They use this secret with my token GitHub give me to validate this token. And then GitHub say, OK, you are really Algolia. And this user is really this user. Now you can use the API to do whatever you want to do according to the scope you have requested. So how does it work more precisely? So first, when I click on login with GitHub, I go on post algolia.com/auth/GitHub. It redirected me on GitHub directly with some parameters. So I was speaking of Algolia application ID. That's the first parameter. There is a redirect URI. It's where GitHub has to redirect me once I have successfully logged in and authenticated, and I've given my consent. And then the response type, it's the kind of authentication I want. I'll come back to this later. And then what Algolia wants to access from my account. So once that's done, GitHub is redirecting me to the redirect URI. So we are going back to Algolia get a request. So internally, in this request, they get the temporary token I got on my browser. And then internally, they just ask GitHub, OK, I have the token from the user. I have my secret. So that's the second part. I have the client ID, client secret, and the code. And from this, I want a final token I want to use to authenticate as the first user. So with this, at the end, Algolia gets an access token, which let them use my account to use GitHub API. So it's a three-part authentication, which is the most common. And that's what you are using really every day, I think, for most of you. And finally, Algolia redirect me to their dashboard. OK, so this is great. That's something we are used to use. But finally, it's something complicated. And it does not fulfill the need to authenticate one user against one API. This is to authenticate a service to use an API as being some user. So finally, how do we authenticate just one user to my own API? I don't care having all these actors here. So in this case, I just want to authenticate against some authentication service, get credentials, and then from these credentials, use some API. And so where there is the user, it can be any client. It can be a web dashboard. It could be a command line client. It could be some script you have done to automate some things. So let's get back to the request Algolia is doing to GitHub. I said there is a parameter which is named response type, which is here code, which is defined by the hierarchy, by the standard of OAuth 2. But actually, code is not the only one. Code is the one you want to use when there are three parts in your authentication scheme. But there are other ways to use the standard OAuth 2 to authenticate user. Actually, there are three others. The one which interests us here is the token way. So for instance, you can just say, hey, I want to get one token for my user, and then I want to use this token directly. So in this case, the dashboard is being redirected to the authentication service. The user say, hey, this is my username, my password, and OK. And then the authentication service redirects to the application, like a web dashboard. And then the web dashboard get a token to reach any API they want. So in this case, we got this. So first, I got to an authentication service. I get an access token. And with this access token, I can reach the different services from the platform in this case. But here, there is another problem. I mean, the tokens are given by some specific service, an authentication service. How do the other services know these tokens are valid? One way to do it is, for example, for the Scalingo API, to ask each time to the authentication service, is this token valid? but it does not work because it would mean the authentication service would be super critical to your infrastructure, or the queries would be double because you have to first authenticate, then you create a token to get some resource, and then it gets to the authentication service again. That's not something you want to do. That's not something you want to build. That's here comes GWT. So what is GWT? It means JavaScript Web Token. So in the OAuth 2 standard, they say at the end, give an access token to the user. But they don't say how should be built this access token. You can put whatever you want. So GWT is just another standard you can use to build access tokens to your user. So GWT provides tokens which are cryptographically signed. It means that only the authentication service, in this case, are able to create them. And the other services which get the token are able to be sure it's only the authentication service which has created it. It can't be forged by anyone else because there is some cryptographical secrets which is shared among my services and other people don't have. So a GWT token is built on three things. There are the header part, which says how the token is signed and which type of token it is. The payload, which says how long a token is valid and any information you want to put in it. In this case, there is the expiration time and the sub, which means subject. In this case, it can be a user ID. You can put some metadata also. There is no rule on what you put in this. You can, the only drawback is that your token gets bigger and bigger according to what information you put in this. And finally, the third part is the signature. So the signature is to apply the algorithm which is defined in the first part, in the header, on the header plus the payload, and then you get something unique thanks to some secret which is only known by the authentication service. So in this case, get back to my OAuth 2 dance. It's often like this it's called. At the end, instead of getting some random token, I get some structured token, which is a GWT. So in this case, when I ask my authentication service, hey, I want to authenticate, I want a token, the authentication service say, okay, here's your token, and it's valid for 1 hour in this case. So in this case, the user gets to the authentication service, authenticate with user password, and get a token back. And with this token, it can access other services of the infrastructure. And these services are able to understand the token and be sure that they are valid. Using GWT has some drawbacks also. And to be really secure, you have to take care of different things. As these tokens are stateless, I mean, a token will be always valid cryptographically because the signature is signing the whole content. You have to make sure that the expiration date is really short, because if you have a token which is just stolen or yes, just stolen, you have no way really to revoke it, or if you need one, you have to get something which is used by all your services, and this is something really difficult to build. Not impossible, but difficult. GWT is a standard. There are libraries in any language for this part. The libraries are usually respecting exactly the RFC, which defines GWT. And in the RFC, it said, check the signature of the token according to the algorithm, which is written in the header. But in the RFC, it's written that known is an algorithm. So it means that if your server is accepting the known algorithm, so anyone could build some token, and known means no algorithm, so there is no signature. So you have to take care to disable, to only accept secured algorithms. And there is this secret, which is shared among your services. And this secret, it's a good practice to rotate it every year, for instance. For instance, in the PCI DSS standard certification, which is the one you need if you want to make bank operations, it's written that cryptographical tokens or keys in your infrastructure should be rotated every year. So that's it seems to be a good practice to do it every year. So in this case, let's get back to just remind the GitHub flow. In this case, we get a token at the end, but the problem is this token is infinitely valid. If we want to put some expiration, we need a way to ask for a new token. Where, for instance, if the token is only valid for 20 minutes or 30 minutes, when it expired, the server will return 4.1, you're not authorized, and in this case, your client, API client, should automatically ask for another token. And that's why in the RFC standard, there are some additional fields which are possible, which are the expires in field with some duration, and a refresh token, which is only known by your authentication service. And thanks to this refresh token, you can ask for other tokens once you have authenticated a first time. And this refresh token should be really revocable. It means you should have some easy way on your authentication service to say, I don't want this refresh token to create new tokens. So to take away, today there are the most common ways you'll find mostly everywhere to authenticate, to build the authentication of an API is first to use simple API keys. The good point on this is it's really convenient for developers because you just take the token, make a call request, and it works. The main issue with this method is that it's difficult to distribute. If you have an infrastructure which is distributed on different zones, and you have different services which have to understand this authentication, it's difficult to get them to have the knowledge on these standard API tokens or static API tokens. So that's why the OAuth 2 norm is standard lets you delegate authentication. It's the three-part authentication I tell you, but also the standard. I mean, with the API keys, there is no standard way to do it. You do whatever you want. You do your kitchen and your project. Usually there is no RFC behind it or anything. OAuth 2 is an attempt to standardize everything and allow also three-part authentication, like I've shown before. And with WT, it lets you make some stateless distributed validation authentication for your services. And all these methods are not exclusive. You can have some API tokens and some OAuth 2 in your application. For instance, that's the case of GitHub, where they have both. They are not using GWT, but they have OAuth authentication and simple API keys for users. So here are the references to the RFCs. So for OAuth and GWT, and the licenses for the icons I've used in this presentation. Thank you very much. So you can find me as Soulou on GitHub, Twitter, whatever you want. If you have any question, I'm here. Thank you.
Do we have questions?
Yes, a lot of
Wow.
Yeah, actually, it's here, and I have one question.
He has the thing,
sorry,
so
I
I
have
think
the
he's
thing
first to
then.
go.
Sorry. So I have a question about the API keys, because you kind of showed in the beginning. So let's take the project that was before, the musicologist, right?
Yes.
So basically, it's a B2C app. You just use it to search for music.
Yes.
And that app is going to be authenticated with two services. One is going to be Dialogflow, and second, Algolia.
Yeah.
How can you move that to OAuth without having any credentials? I mean, the user is agnostic of what's going on behind, right?
Actually, for the musicologists, it will depend how Dialogflow and Algolia, what they are providing. I don't know enough Dialogflow to tell you if there is some simple token or OAuth authentication. For Algolia, I don't know how. As currently Algolia doesn't have OAuth, it's the service should ask for some API key today, and I don't know how it can be designed easily, because on your phone it's difficult to give some API key from your own data from Algolia.
But even for the web, let's say, you know, like I have a website.
Yeah.
I don't know. Let's take Amazon, and Amazon is using Algolia. It's not, but you know, let's say they're using Algolia. But me as a customer, I don't know what they're using behind, right?
Yeah.
So how would I know? Like, how can what I'm going to use to identify what's the meaning behind, like, what Amazon is going to.
Actually, what in this case Amazon could do is that Amazon has some admin tokens for the account. They can just say, hey, I want to create a temporary scope limited token I will give to the client, to your browser finally, and then your browser will use this token to hit Algolia directly, for instance. That's something you can do.
Cool, thanks.
Next questions. So, okay, I'll let you do that, Paul-Louis.
Thanks. I guess Algolia has OAuth because they have GitHub identification and Google as well, I guess. And the answer to the question that he asked would be using the common one between the two services. But the question that I wanted to ask was, you said that it's not impossible to retrieve the token created by cryptography, and I guess it's a SHA encoding. So how could the service retrieve the token if it's created by this method?
Just for the first part, Algolia doesn't have OAuth. It's GitHub and Google who have OAuth, and Algolia is using it. Okay. That's just to, sorry. In this case, actually, you have to get then in a GWT token, the first part, which is the header and the payload, which are the two first parts of the token, are not encrypted. They are clear. It's just base 64 encoded, and then how it is signed. It's you are concatenating the header and the payload, and there is some secret which is a key. It can be a keeper with public and private, or it can be something symmetric. This key, the secret, is only known by your services. So, for instance, when the authentication service provides a GWT token, the user sends it to this API. This API will just read the header and the payload, which are clear. It can be read. And in the backend, this API has access to the secret. So with the secret and the content of the token, it generates, again, the signature, and it has to match the signature which is embedded in the token. And at this point, the API will be sure that the token has been generated with the good key, which is also provided, accessible from the authentication service. Does it answer your question?
Yeah. Who else has a question?
Thanks. You said before that in this case, that the key is available for 1 hour. So it's just a small dumb question. What happened after 1 hour? You ask the customer to log again to get a new token, or because you said you can't revoke it, yeah. So you have to have a short lifetime. So yes. What happened after if everything is good?
Okay, so that's why in this slide, after the end of the authentication exchange with the authentication service provides what is called a refresh token. And this refresh token is only known by this service. There is no common knowledge of this refresh token. So in this case, so there is an access token, which is a JWT token, which is only valid for 1 hour. And when it's not valid anymore, the client still has a refresh token and will just ask, hey, I have a refresh token, it's valid, and please give me another access token to keep using the other services. Why is it more secure? It's because the refresh token is only known by one service, so it's much more easy to revoke it. There is no need to go to all the services you have in your infrastructure.
Is that replies your question?
Yes, I have a question here. How long did for the refresh token? Is it forever or?
Usually, what is said in the OAuth 2 RFC, it said refresh token can be valid forever until revocation. But if you have the opportunity to ask the username and password to your user again, for example, it's going back to your dashboard or anything, it can be a good practice to renew it at that moment. So then you get a new refresh token to get a new access token. But it can be forever.
Okay, thanks.
Some Dewey, there is one in the front. I think
Thank
it's
you.
the last one.
Yeah, so my question was on the implementation wise, and I've been wondering how you have handled the migration from basic-auth, basic authentication to the actual implementation you made.
Actually, in our case, before this API was a kind of monolith doing the authentication and a lot of other things. And actually, for a while, we were doing some double writings to this service and this service, and clients which were using the old method were able to authenticate using this, and clients which have been updated, the command line interface and all other tools are able to use this. And so there is a common period where both are still accessible, and then we'll shut down the old one.
Okay. Thanks.
All right. Okay, there is a last one, so I cannot say no to someone who's like, can I? Okay, you can.
Thanks a lot. Why don't you use in your scenario OpenID authentication
Actually,
without authorization?
Actually, OpenID could be used. I mean, it's not something I don't want to use. It could help us managing the. Actually, OpenID is a standard which has been which can be plugged in OAuth 2 usually. That's how I see it. On some websites, you can use your OpenID identity to log in for your account. And actually, it could be used. I don't have the real precise answer for this, because I think it's possible, that's sure. And but that's not the choice we've done so far. But for no special reason, actually it adds some abstraction over OAuth 2, so it's a little of complexity. But the advantage is that there are a lot of different OpenID provider out there, and then instead of having all our users authenticating against our service, we can have users from elsewhere authenticate. Actually, who could use our API without our API knowing their real identity, finally.
All right, so thank you very much, Leo. I think we can give him a bit of applause.